Let's look at some of the different drive systems that we have examples of here. Allen wrenches are one way that fasteners are driven. Here we have a button head Allen drive. Here we have a headless socket screw. Here we have a large diameter fine thread pitch socket screw. Another fine thread pitch socket screw. A cadmium coated and a zinc coated bolt and nut. A external star washer mounted under the head of this nut. A dual drive nut that lets you use a slotted screwdriver or a hex driver. And again, you can see a range of examples of other different drive styles. In addition to the hex, we have Phillips, slot, and a few distinct head types here that include ones that we introduced in earlier modules, like the truss head, the pan head, the round head, and this is a particularly unique head style that has a socket drive and holes that are drilled through it so that it can be wired in place. Bolts are most typically used in combination with nuts, and there are nuts in different shapes and different styles to meet specific needs. We have what are called hardened nuts, and that's characterized by the black surface, and that tells me that it's rated for a specific grade of use. We have square nuts. We have standard nuts. This one is zinc plated. This one is made out of copper. This one is made out of steel. This one is called a coupling nut that has the ability to join two pieces of rod or two different fasteners together because of its length. This is called a jam nut or a thin nut, and I'll show you a little later in our demonstration how jam nuts are used. This is a spring nut that's used with this strut system that's called unistrut, which is used for hanging mechanical systems from the ceiling. Here we have something called a nye lock, which is a locking nut that has a plastic interior that resists loosening up under vibration. Some nuts are installed by hand and have what are called knurled faces or serrations cut into the nuts. We have wing nuts, we have thumb nuts, we have T-nuts, which are used as a transitional hardware between wood and machine bolts, and we'll look at some of the applications of that. And we have threaded inserts that can be driven into wood and have internal machine screw threads. We also have things like this wooden nut that's made out of laminations like plywood. We talked about national coarse and national fine as two of the standards that are used for machine screws. And those machine screws always have parallel sides. Pipe thread is different in that it tapers. And the reason that pipe threads taper is so that they are more useful for self-sealing. And again, this isn't done by the pipe alone. This is done in combination with either what's called thread tape or with pipe dope, which is put onto the threads in advance of them being sealed together. But because they taper, they're more effective at sealing the possibility of whatever's being transferred through that pipe, be it a water or gas, of potentially leaking out. Nuts and bolts will frequently be used in combination with washers. And there are standard washers or SAE washers like we have right here. The proportional relationship between the opening and the outside diameter of a flat washer or an SAE washer is that it's about twice as large around the perimeter as the opening in the inside. Here we have a 5/16 flat washer in zinc plating to resist oxidation. Here we have one in plain steel. Here we have two examples of what are called fender washers. And fender washers have a distinct, disproportionate correspondence between the hole that screw or bolt goes through and the outside perimeter. And this is for being able to distribute load over more surface area. So fender washers are often used when you're hanging off a minimal number of fasteners going through a material that is thin or soft, and it distributes more of the force or load of that nut and bolt compressing together over more surface area, which makes it less prone to tear out. And then here's a square washer that's used in conjunction with these unistrut systems. A beveled washer, which is used on I-beam construction. And then a couple of examples of different types of lock washers. If the function of flat washers is to distribute load, then the function of lock washers is to keep the nut held in tension against that bolt so it's less prone to loosen. And the way that does that is through a kind of spring tension. When the nut compresses against the shoulder of the bolt, it pushes down or compresses that spring element in the split washer, and that force pushing back reduces the probability of that nut coming loose. So we typically find lock washers used anywhere where we might have concerns about a nut loosening up, like on a bicycle wheel. These are two other types of lock washers. This is a star washer with internal threads and a star washer with external threads or tines. Most fasteners are commonly treated to minimize oxidation when they're made out of steel because steel is prone to rusting. But in our practice, rusting that hardware might be exactly what we want. Or it might also be the case that we're wanting to be able to weld on these fasteners, and we cannot weld on any of these fasteners that have secondary metals coating them, like the zinc coating that we see on these examples here, or this painted treatment that we have on this fastener, or the cadmium coating that we have on this fastener. Those secondary metals, when heated up, will volatilize and generate fumes that are extraordinarily unhealthy to be breathing and can result in an illness called metal fume fever. So we're often selecting bare steel hardware for welding applications, or to be able to oxidize them to get a good color match between the hardware that we're working with and the finish on the metal components of our particular piece. It's also important to understand that not all bolts and nuts are made out of the same grade of material. And there is a grading system that is used for mechanical hardware so that when engineers are building a bridge or something that has structural loads on it, that there's a calculable strength yield of those fasteners. And on probably on some of the fasteners we have here, there we go, you'll see this graphic that is on the top of those fasteners, and that tells us something about what is called the grade of that bolt. And that grade of that bolt has a mechanical values associated with it that tell us about its resistance to bending forces or its resistance to shearing forces. So general purpose fasteners are not graded. The numerical system, I believe, starts with a grade 5 and then goes up to a grade and then steps up to a grade 8. And because I don't use a lot of mechanical fasteners for structural purposes in my own practice, I'm less familiar with that grading system. But this information is available online should you have an interest in diving a little bit deeper into it. So let's look at some of the other mechanical fasteners that we have here on the table that have machine threads. So here we have carriage bolts. Those actually don't have any drive system, and they have a smooth head on them. So this is a zinc-plated carriage bolt, a plain steel carriage bolt, a hex nut, a square nut. These are called sex bolts, and they're used with mating parts like we see here that are hollow tubular pieces of hardware that have no drive system on one side of them and a very low profile drive on the other side of them. And these are typically used for gathering or bundling sheets of soft material together. It might be a detail that you would find in something like a book binding. So we have hanger bolts, which we looked at during the wood screw module, where there's a wood screw on one side and machine screws on the other side. We have this post hanger. We have tubular material that's threaded on both ends that allow us to be able to extend the length of a fastener. We have U-bolts. We have riser bolts that can be used underneath a table leg for raising or lowering or leveling that table leg. This one is all steel. This one is what's called phenolic, which is a wear-resistant composite with a threaded post. Here we have something called turnbuckles. And turnbuckles are typically used for tensioning cables. So one side of the turnbuckle will have right-handed threads, which is the most common direction for all threads to move. And the opposite side will have left-handed threads so that you're able to turn from the center, and as you turn from the center, it will either lengthen or shorten the distance between those 2 points. And we have eyelets on 2 sides and one with an eyelet and a hook. Here we have what's called a drop forged eye. Here we have a zinc-plated galvanized eye and another zinc-plated galvanized eye. The drop forge eyes are going to have a load rating because they're used for lifting heavy equipment, whereas these other screw eyes are not made out of a graded material, and although they may have recommendations in the package as the maximum weight that is recommended for them to lift, they really don't have what we would consider to be an engineered load rating.